All right, hello guys. So yesterday we looked at solving quadratics by graphing. Today we are going to be starting our last method of solving quadratics, which happens to be solving by factoring. So before we actually get started with that, I do want to make sure that you know what the word factoring means, that you understand what that process is. So let's start with just a number. Let's not consider any x's yet. Let's say that I was going to factor the number 18, okay? What I would be doing is I'd be thinking about what are some numbers that go into 18, and there's lots of different ones I could use. The first ones that come to mind for me are 2 and 9. Okay? So I could split 18 up into 2 and 9. But then I could also factor the number 9. I could say that 9 is the same thing as 3 times 3. And then I'm done factoring. So what I've just done to the number 18 when I factored it is I broke it apart into some smaller numbers. And that's exactly what factoring is. If I factor something, that means that I break it apart. Okay? So what I'm doing is I'm taking a bigger number, I'm breaking it into smaller pieces so that it's easier to work with. Okay? Something else about factoring. Because I want simpler answers when I factor, factoring works great if my answers have to be whole numbers, okay? Or they can actually also work for fractions. So if you're on a multiple choice test and you happen to notice that all of your answers are whole numbers or all of your answers are fractions, then that quadratic can probably be factored. If your answers happen to be really ugly decimals or they have square roots involved, factoring is not the way that you want to go. Okay? The other thing about factoring, if I want to solve an equation by factoring, I have to make sure that first it's equal to 0. Okay? So as long as you have made sure of those three things, you understand what factoring is, your numbers are whole numbers or fractions, and your equation equals 0, then you're good to go. You can solve by factoring. So let's actually practice that. Okay. There's my clear button. So if I was going to solve number 1, just as a quick reminder, I'm going to label this. Whatever number is with x squared is A, whatever number is just with x is B, and whatever number is by itself is C. Okay? Just a quick refresher there. Let me make that just a little bigger so you can see this. Okay. So A, B, and C. When I start to solve by factoring, I'm going to make myself a little organizational tool. I'm going to draw an X. C, or the number that's by itself, always goes on top of that X. So in this case, 15 goes on top. B, or the number that's with X, always goes on bottom every single time. Okay? So if I want to break these numbers apart, now what I'm looking for is two numbers that will multiply to 15, but will also add to 8. So when I think about the numbers that multiply to 15, the ones that pop in my head first are 3 and 5, which is good because they also add to 8. So 3 and 5 are going to go on the sides of my X. Okay? So here is how I actually write out my factors. I've split up my numbers. I'm also going to split up this x squared into two pieces. So I'm going to draw two sets of parentheses. Okay? If I split up this x squared right here into two parentheses, that means each parentheses gets one of my x's out of the x squared. Okay? Then I also split up my 15 and my 8 into 3 and 5. So 3 goes in one parentheses, and 5 goes in the other parentheses. These right here are my factors. If all that the instructions say is to factor, then I stop right there, I'm done. Factors go in parentheses, okay? But my instructions here say to solve. So here's how I actually go a step farther and solve. We had this whole equation equal to 0. Now we've broken this equation down into two pieces. So I'm going to take each piece, the x plus 3 and the x plus 5, and set them equal to 0. Okay? Well, if I solve these equations, the To solve x plus 3 equals 0, I subtract 3 to the other side, and I get x equals negative 3. If I was going to solve x plus 5 equals 0, I subtract the 5 to the other side, and I get x equals negative 5. So my factors were just pieces in parentheses. My solutions are what do those pieces actually equal. Then I'm done. Okay? So make sure you know the difference there. Alright, so let's move on to number 2. And you may notice number 2 looks a little bit different. And the problem with number 2 is that it's not equal to 0. So before I actually start factoring, I've got to fix that problem. So the first thing I do, this is a negative 2 here. So I'm going to add it back to the other side, make that equal to 0. So plus 2 gives me n squared minus 10n plus 24 equals 0. Now I'm ready to factor. Okay? So I'm going to draw out my x. And again, C, where the number by itself, goes on top. So 24. And B, the number with x, or n in this case, goes on the bottom. And I do want to draw your attention to one thing. Don't forget if your number has a negative, take that negative with your number. So this is a negative 10 here, not a positive 10. So now I am looking for two numbers that multiply to 24 and add to negative 10. Well, the first thing that pops in my head is that 6 and 4 multiply to 24. So I can probably do something with those. But I don't want to leave them positive. They've got to add up to negative 10. How do I make them add up to negative 10? Well, I make them both negative. So now when I write out my factors, I'm going to split up my n squared. So each parentheses gets an n. Now I can write my minus 6 and my minus 4 with those two n's. And again, there are my factors. If I get instructions that say factor, that's all I do. I stop right there. So I'm going to label these as factors. But if I actually want to solve, which I do in this case because that's what my instructions tell me to do, I want to know where do each of these two pieces equal 0. What does n actually equal? So I take n minus 6, set it equal to 0, and I take n minus 4, set it equal to 0. And this time if I solve, I have to add 6 to the other side, and I get n equals 6. On that second piece, I have to add 4 to the other side. So I get n equals 4, and then I'm done. There's my solutions. And something you might notice here on both 1 and 2, and this will always happen, your factors and your solutions should have opposite signs. So if I have two negative factors, I should end up with two positive solutions. If I have two positive factors, I should have two negative solutions. So we are almost done. There is one special case that I want to show you when you're factoring. Let's say you get something like this, like number 3, okay? It is equal to 0, which is good, but I notice it's a little bit short. Here's how I factor this. If I go draw out my x, okay? Negative 9 is still c. It's the number that's by itself. It's still going on top of the x. But the problem is I don't have a b. There's not a number that's just with an r. So in that case, I put 0 on the bottom because there are no r's there in the middle. So I am now looking for two numbers that multiply to negative 9 and add to 0. Well, two numbers that multiply to 9, that's going to be 3 and 3. How can I get two 3's to equal 0? Well, if I do 3 minus 3, that will give me 0. So my factors in this case are going to be r plus 3 and r minus 3. Okay? If I want solutions, I take each piece and set it equal to 0. So r plus 3 equals 0, r minus 3 equals 0, and when I solve, I get r equals negative 3 and r equals positive 3. And then I'm done right there. Okay? One thing I do want to mention about things like this where you're missing a number in the middle, if this number at the end, so in this case 9, if it happens to have a square root, there is a shortcut. If you notice here, when we factored this, we got the square root of 9. That will happen every time. This is called a difference of squares. So, for example, let's say that you saw something like this, and it said solve. I don't even have to draw out my x. I already know, hey, there's a minus sign, so it's a difference. 64 has a square root. So automatically when I factor this, I already know it's going to be x plus 8 and x minus 8 because of the fact that 64 has a square root. That is a difference of squares. Okay? So when I solved it, I would get x equals negative 8 and x equals positive 8. You don't have to use that shortcut, but it is there if you want it. So go ahead, get started on your activity for today, and let me know if you have any questions.